Hi there and welcome back to Having Fun with Chemical Formulas. I hope you were successful with Activity 6. If you were, then well done, because basically you've now become fairly proficient in producing ionic formulae. Okay, the last real step that we're going to look at with respect to ionic formula is during this tutorial we're going to look at complex ions. So the first question we need to ask ourselves is, what is a complex ion? Well, complex ions are basically ions which are made up of two or more elements. In most cases, they tend to be anions. Now, the key to using complex ions when we're making ionic formulae is to make sure we deal with them as a whole. They have their own individual charge, and that's the one that we really need to deal with. The complicated part comes when we have multiples of these complex ions. So what type of complex ions do we have? Well, on the left-hand side you can see a variety that we're going to use during this activity. We've got things like hydroxide ions, OH-, sulfate ions, SO4 2-, carbonate ions, CO3 2-, nitrate ions, NO3-, and ammonium ions, NH4+. This is one of the few cations that we have. So how do we use them? Well, the process is really simple. It's exactly what we've been doing in the last one. As long as you treat the complex ion as a whole, you should have no problems. So make sure you write down what your positive ions are. Make sure you write down your negative ions. See if their ions add up to 0. If they do, write down the atoms that you've got, and that's it. If they don't, then what you'll then have to do is add multiples of either your positive or negative ions. The key to using complex ions, and probably the most complicated part of it, is to realize if we've got more than one complex ion, all we do is put the whole complex ion in brackets and then write as a subscript the number of those ions that we require. It's probably easier if we try a few examples. So make sure you've downloaded Activity 7 and work through the examples with me. Okay, let's get started. Okay, example 1. In this case, we're going to make the ionic compound sodium hydroxide. So to start off with, we need our positive ion, sodium. We'll put that in the CpZ, and then we need our negative ion, hydroxide, OH-. Join the two together, and there's the chemical bond. So let's check and see how their ions compare when we can put them together. So in the calculation zone, we'll put the number of positive ions, +1. The number of negative ions is -1. When we combine those together, hey, we get 0. This means that the compound is now stable, so we can ignore this middle piece. So in order to work out what the ionic formula of this compound is, we write down the symbols and the number of those atoms that we've got. We've got 1 sodium and we've got 1 hydroxide. Remember, hydroxide is written OH. So the formula overall is NaOH. That means 1 sodium joined with 1 hydroxide. Easy. Okay, let's look at example 2. In this case, we're going to use sodium. We're going to make the compound sodium sulfate. Again, we've got sodium, which is a 1+ ion, but we've got this complex ion sulfate, 2-. The key to this is realizing that the SO4 stays as it is. All we're going to do is start looking at the ions. So let's put the positive over in the CpZ. There we go. Now let's put the sulfate over in the CpZ. Join them together with a chemical bond, and then let's whip over to the calculation zone and compare the ions. Well, we've got 1 positive from the sodium, but we've got 2 negatives from the sulfate. Note that the 2 negative is that superscript that you've got on the sulfate ion. When we combine those together, here we go, we get the -1. Now this is the point where we don't panic, we take a deep breath and we logically work through the problem. We need to convert that -1 into 0. So what must we add? Well, it's simple, we must add another positive ion. The only positive we can add is sodium. So let's put one over there and join it together. Alright, let's do the calculation again. So in this case, in the CpZ, we've got 2 positives joined with 2 negatives. Hey, that's 0. They're now stable. So how do we write the formula? Well, we've got 2 sodium ions. Remember, the number of ions that you've got goes down as a subscript. So it'll be Na2. The sulfate is always written as SO4. So the formula must be NO2SO4. Okay, let's do one more. In this case, we're going to make the ionic compound calcium hydroxide. The calcium is our cation, 2+. Our hydroxide is our anion, OH-. Okay, let's put our calcium over in the CpZ. There it goes. And our hydroxide, and combine them with a chemical bond. Okay, let's do the calculation zone. So the number of positives in the CpZ is 2+ from the calcium. But the number of negatives is 1-, that's from the hydroxide. Combine those together, we get an overall total of +1. They do not equal 0. Deep breath time. Okay, how do we convert +1 into 0? We need to add a negative. The only negative we can add is the hydroxide, so let's do that. Join it together with a chemical bond. Alright, let's go back to the calculation zone and see what we've got now. We've got 2 positives, that hasn't changed, but now we've got 2 hydroxides, each one having a negative charge. So they combine together to have an overall negative charge of 2-. +2 plus 2- gives us 0. It's now stable. Now, how do we write this? Well, we've got 1 calcium ion, so that's just written Ca. But we've got 2 hydroxide ions. Now remember, hydroxide is always written OH. So because we've got more than 1 OH, we have to put the whole thing in brackets. So we have 1 calcium, then we have to write brackets with OH inside, and then the number of OHs that we have goes as a subscript. We've got 2 OH-. So the formula that we have for calcium hydroxide is Ca brackets OH twice. So that means we've got 2 OH ions joined to 1 calcium ion. Okay, so now what we want to do is try and practice some of these ideas. It is going to take practice, but follow the process through. Use this video to help you as you go through the examples, and I'll see you at the next tutorial. Okay, so good luck on activity 7, and thanks for watching.